Hello and welcome back. In this question, we are required to calculate the minimum force in the rope that is needed to move the crate up the ramp. Now, there are 5 steps to tackling this question. The first step is drawing our X and Y axis. The second step is drawing our forces. Third step is converting the weight force into its X and Y component. And then we use our equations, which will be sum of Fx equal to 0 and sum of Fy is equal to 0. And then we are able to solve for X. So applying the first step, our X-axis will be along this direction. Our Y-axis will be perpendicular to the X-axis as such. And then once we've got that, we can now apply our forces. So we have our weight force, which is going directly downwards. We have the normal force, which is 90 degrees to the surface. And we have our frictional force, which will be acting in the opposite direction to the motion. Since the rope is pulling the crate up the ramp, the frictional force will be going down the ramp. And I'm going to denote that with F, small f. Okay, now we've got that, we can now break up our weight force into its X and Y components. So to draw up the X component, it has to be parallel to the X-axis. So it will be going like this. And then the Y component will be going along the Y-axis. And there's my right angle. Now the angle between the Y component and the weight force will be 20 degrees. Okay, so now our Y component will be W cos 20, since it's adjacent over hypotenuse. And my X component will be W sine 20. Since it's opposite over hypotenuse. All right, now that we've solved all that, we can now use our equations. Sum of Fx equals 0 and sum of Fy equals 0. So sum of Fx is equal to 0. And I'm going to consider this direction as positive. So I've got the force in the rope, which is F. Got the frictional force acting downwards, so it's a negative. And I've got the X component of the weight force also going down the ramp, so that's negative as well. W sine 20 equals 0. Now I want force to be the subject, since that's what we're calculating. So F is equal to the frictional force plus W sine 20. So I wanted F on one side and the rest on the other side. So now my force is equal to, now my frictional force is the coefficient of friction times the normal force, which you can find in the formula sheet. We know our coefficient of friction is 0.25, so it will be 0.25 times N, which I don't know just yet, plus the weight force, which is mass times gravity. So 95 kilograms, times that by 10, and you get a weight force of 950 sine 20. Now I can't solve for X because I don't know the normal force. So now I have to use sum of Fy equals 0 to calculate my normal. So sum of Fy equals to 0, and I'm going to take this as my positive direction. So we've got the normal force, which is acting in that direction, minus the Y component of the weight force, which is W cos 20 equals 0. Therefore, N is equal to 950 cos 20. So therefore, N is equal to 892.7 newtons. Now that I've got my normal force, I can then go and sub this back into here. So therefore, F is equal to 0.25 times 892.7 plus 950 sine 20. So plug those values into the calculator and you get a force of 548 newtons. So to sum up, we first draw our X and Y axes. We then draw our forces. We convert the weight force into its X and Y components. And then we use the two equations, sum of Fx equals 0. Then we get our force equation. Now, since we don't have our normal force, we need to apply the sum of Fy equation to calculate our normal force. Once we've got our normal force, we can then go and plug that back into our force equation to eventually find the force in the rope.